According to the National Electrical Code, it is not permitted to mix wire sizes on the same lugs unless the lugs are specifically designed for that purpose and are approved for the use of different wire sizes. This is because different wire sizes have different ampacities, and mixing them could create a safety hazard. The larger wire may not fully insert into the lug, resulting in a poor connection and potential overheating. The torque required to tighten the bolts may differ between the two wire sizes, which could lead to the connection loosening over time. The tap rule does allow for a reduction in wire size for short taps under certain conditions. However, this rule does not apply to double-lugging breakers. Double-lugging a breaker is not allowed because it creates a parallel path for the current flow. This can result in unequal current distribution and overheating of the breakers or the wiring. Instead of double-lugging or mixing wire sizes, you could consider alternatives. Firstly, consider a gutter splice. Install a gutter below the panels and splice 3/0 wires from each panel to the 500 kc mill feeder. Secondly, use a sub-panel. Install a 225 amp sub-panel adjacent to the main panels and feed it with 500 kc mill wiring. Then, use 3/0 wiring to connect the main panels to the sub-panel. The best solution for your particular situation will depend on the specific layout of your electrical system and the available space. However, it is important to ensure that the installation meets all applicable electrical codes and standards for safety and reliability. When dealing with electrical installations, safety and code compliance are paramount. Here's a more detailed look at the issues and alternatives. Considering the prohibition of mixing wire sizes on the same lugs, understanding the underlying reasons is crucial. Wires of different gauges possess varying current carrying capacities, known as ampacities. When a smaller gauge wire is connected alongside a larger gauge wire on the same lug, a potential safety hazard arises. The smaller wire, being unable to handle the same amount of current as the larger wire, can overheat and potentially melt its insulation, leading to a short circuit or fire. Furthermore, the physical connection itself can be compromised. The larger wire may not fully seat within the lug, leading to reduced contact area and increased resistance. This, in turn, can cause localized heating and further degrade the connection over time. The tightening torque also plays a significant role. Different wire sizes require different torque values to ensure a secure and reliable connection. Applying the incorrect torque can either damage the wires or result in a loose connection, both of which pose safety risks. Double-lugging breakers with two conductors are connected to a single breaker terminal is also generally prohibited by the NEC. This practice creates a parallel current path, which can lead to an equal current distribution between the conductors. One conductor may carry a disproportionately larger share of the current, causing it to overheat and potentially fail. Additionally, the breaker itself may not function correctly under these conditions, as it is designed to protect a single circuit with a specific impedance. Alternative solutions offer safer and code-compliant ways to achieve the desired electrical distribution. Installing a gutter, also known as an auxiliary gutter or wireway, provides a convenient and organized way to splice conductors. The 500 kc mill feeder can be terminated in the gutter, and then appropriately sized conductors, such as 3/0, can be spliced to feed each panel. This method ensures that each conductor is properly sized for its respective load and that all connections are made within a listed and labeled enclosure. Using a sub-panel offers another viable alternative. The 500 kc mill feeder can be connected to the main lugs of the sub-panel, and then individual circuits can be run from the sub-panel to each of the original panels using appropriately sized conductors. This approach provides increased flexibility and allows for future expansion if needed. When implementing any electrical installation, it is essential to consult the NEC and local electrical codes for specific requirements. The NEC provides detailed guidelines on conductor sizing, overcurrent protection, and installation methods to ensure safety and reliability. Furthermore, it is always recommended to engage a qualified electrician to perform the work, as they possess the knowledge and experience to ensure that the installation is done correctly and in accordance with all applicable codes and standards. Always prioritize safety and code compliance when working with electricity. Improper installations can lead to serious consequences, including electrical shock, fire, and property damage. By following the NEC guidelines and seeking professional assistance, you can ensure that your electrical system is safe, reliable, and compliant with all applicable regulations. Remember that electrical codes are updated regularly, so it's crucial to stay informed about the latest requirements. Consider attending electrical training courses or workshops to enhance your knowledge and skills. Understanding the principles of electrical theory, wiring practices, and safety procedures is essential for anyone working with electricity. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Never attempt to perform electrical work if you are not properly trained, as this can put yourself and others at risk. Always disconnect power before working on any electrical circuit. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Inspect all tools and equipment before use to ensure they are in good working condition. Follow lockout/tagout procedures to prevent accidental energization of circuits. Be aware of the potential hazards associated with electricity and take precautions to mitigate those risks. If you are unsure about any aspect of an electrical installation, consult a qualified electrician. Prioritizing safety and following best practices will help ensure a safe and reliable electrical system. The NEC is a comprehensive document that covers a wide range of electrical topics. It is organized into chapters, articles, and sections, making it easy to find information on specific subjects. The NEC is updated every 3 years to reflect changes in technology and best practices. Staying up to date on the latest NEC requirements is essential for anyone working in the electrical industry. Many resources are available to help you understand and apply the NEC, including training courses, workshops, and online forums. Consider joining a professional electrical organization to network with other professionals and stay informed about industry trends. Electrical safety is a shared responsibility. By working together, we can create a safer environment for everyone. Remember to always prioritize safety, follow code requirements, and seek professional assistance when needed. This will help ensure that your electrical system is safe, reliable, and compliant with all applicable regulations. Also, the NEC addresses the proper methods for splicing conductors, including the use of listed and labeled splicing connectors. These connectors are designed to provide a secure and reliable connection that is suitable for the specific application. When splicing conductors, it is important to follow the manufacturer's instructions and use the correct tools. Improperly spliced conductors can lead to overheating, arcing, and other hazards. The NEC also covers the proper methods for terminating conductors at equipment terminals. Terminals must be properly sized for the conductor being used and must be tightened to the manufacturer's specified torque. Loose or improperly tightened terminals can lead to overheating and equipment failure. In addition to the NEC, local electrical codes may also apply. These codes may be more stringent than the NEC and may address specific local conditions. It is important to be familiar with both the NEC and local electrical codes when performing electrical work. Local electrical inspectors are responsible for enforcing electrical codes and ensuring that electrical installations are safe and compliant. If you have any questions about electrical codes or installation practices, consult with your local electrical inspector. They can provide valuable guidance and help ensure that your electrical installation is done correctly. Remember, electrical safety is everyone's responsibility. By following code requirements, using proper installation methods, and seeking professional assistance when needed, we can create a safer environment for everyone. The NEC provides specific requirements for conductor ampacity, which is the maximum amount of current a conductor can carry safely. Conductor ampacity is determined by the conductor size, insulation type, and ambient temperature. It is important to select conductors with sufficient ampacity to handle the expected load. The NEC also provides requirements for overcurrent protection, which is designed to protect conductors and equipment from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, must be properly sized to protect the conductors and equipment they serve. The NEC also addresses the proper grounding and bonding of electrical systems. Grounding and bonding are essential for safety, as they provide a path for fault current to flow back to the source, tripping the overcurrent protection device and de-energizing the circuit. The NEC provides detailed requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. Proper grounding and bonding can help prevent electrical shock and minimize the risk of fire. The NEC also includes requirements for wiring methods which specify how conductors are installed and protected. Wiring methods include conduit, cable, and raceway systems. The NEC specifies the types of wiring methods that are permitted for different applications and provides requirements for the installation of these wiring methods. The NEC also addresses the proper installation of electrical equipment such as panel boards, switchboards, and transformers. Electrical equipment must be installed in accordance with the manufacturer's instructions and must be properly grounded and bonded. The NEC also includes requirements for hazardous locations, which are areas where flammable gases, vapors, or dust may be present. Electrical equipment installed in hazardous locations must be specifically designed and approved for use in those locations. The NEC also addresses the proper installation of low-voltage systems such as fire alarm systems, security systems, and communication systems. Low-voltage systems must be installed in accordance with the NEC and other applicable codes. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By following the NEC requirements and seeking professional assistance when needed, we can create a safer environment for everyone. And remember, while some tasks may seem simple, working with electricity can be dangerous. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. By taking the necessary precautions, you can help prevent electrical accidents and ensure the safety of yourself and others. Stay informed, stay safe, and always respect the power of electricity.